All right, guys, today we're actually talking about surface area. We're going to spend about the next week, I would say, so 5 or 6 days on surface area and volume of different figures. So this is actually content you were meant to cover in fourth quarter of last year, so we're just sticking it in here in our geometry unit because this is where we felt like it fit best. So today we'll do surface area of prisms and cylinders, and then tomorrow we'll talk about volume of prisms and cylinders, and then we'll work on pyramids and cones early next week. So here first, let's talk about surface area. Surface area is always a little bit more challenging than volume because we're talking about the outsides. Like, think of it as wrapping a present. How much paper do we need to cover the outside of that box? And so here it says the surface area S of a rectangular prism is the sum of the areas of the bases and the lateral faces. So they're saying that these red, so this bottom would be red too, but it's not in our figure. Those are your bases, and then everything that would be vertical is called a lateral face. So if you think about it, this is how it would be sketched out. Like if it was flat, we also call this a net, which is just a drawing of our 3D figure in a 2D format. These would be your bases where you have length times width, and then these two bases would have the same area, so you have two of those. These two lateral faces, these two, would be the same. So they're saying that this is width. So these two would be the same. That's your purple one. And then these two would be the same. So you have two of each of those. Now, not all prisms are rectangles, so it really just kind of depends on what your shape is, because we're also going to do some triangular prisms. So you just want to take whatever the area would be of each little piece and add them all together to get the area of your full surface. So if we take a look at some examples here, I know if I go straight up, this would also be a 3, and straight up, this would also be a 5. So I know I have two of these. I'd have the top piece and the bottom piece. So I would have 2 of 3 times 5s, because areas of a rectangle is just length times width. So this is my 5 times 3 would be my length times my width. I know I have 2 of these sides, these tall sides. So I would have 2 5x6s, because if I go straight across, this is still a 6. And then lastly, can I erase? Perfect. Lastly, we would still have these very front and back pieces. So this piece and that piece. So I'd have 2 3x6s. So if I add these all together, I'm just going to type the whole string into my calculator. It's 126 square inches. Okay, and it's square inches because it's like we're covering these in little 1 by 1 inch squares. We would need 126 of these little 1 by 1 inch squares to cover this rectangular prism. Okay, so same thing on this one. We'd have 2 2x3s. We would have 2 3x4s. And we would have 2 we had 3x4s. We would have 2 2x4s. And then we can add that all together. To get 52 square feet. And again, that's like we're taking little 1 by 1 foot squares. We would need 52 of those to cover this rectangular prism. Surface area is area of the bases plus area of the lateral faces. So again, this one is a net of a triangular prism. So there's no set formula per se, but we would have for our triangles, 2 times 1/2 times base times height. And then we would have these pieces where you have length times width, where the length and the widths will probably vary, although it looks like they might have the same, if you want to call these lengths, they would all have the same length, but they have varying widths, it looks like. So there's not always a set formula or a nice, neat formula, but you can still figure it out based on your net here. So if we do a triangular prism, I know I'm going to have 2 of these triangle sides. So 2 times 1/2 times, it looks like my base is 3 and my height is 4. Then I'm going to have a 4 by 6. It looks like I'm going to have a 5 by 6. And then this would be a 3 by 6. So again, I'm just going to put the whole string in my calculator here. And that gives me 84 square meters. All right, another example here. I'm going to have 2 of these triangle bases. So that would be 1/2 times 5 times 12. Then it looks like I have a 13 by 3. This back piece would be a 12 by 3. And then this little corner piece, I think, would be a 5 by 3. So again, I'm going to type that whole thing in. And I get 150 square meters. All right, the last type of shape we're going to talk about today is a cylinder. So again, we're going to look at its net. And then we're using circles. So in this case, we really just need a radius and a height, because I'm going to have my 2 circle pieces, which are, the area for a circle is pi r squared. But then this piece, the length that would have to wrap around our circle is diameter. And I don't know if you remember, but diameter is 2 pi r. So this would be 2 pi r times height. So for a circle, or I'm sorry, a cylinder, we end up with this formula, which is still not the prettiest, simplest formula, but that's where it comes from. So you would have your 2 circle pieces, and then you would have a rectangle that is your diameter times your height. So for this one, we have our 2 circle pieces, so we want 2 times pi r squared. And then we want our diameter, which is 2 pi r times your height. All right, and in this case, we do have exact form and approximate form again as well. So let me show you that in your TI-30. So I'm just going to type it in just like I wrote it. 2 pi times 3 squared plus, and all of these mean multiplication. You could separate these with multiplication signs if you want. 2 pi 3 times 6. So this is my exact form. If they ask for exact form, it'd be 54 pi. That means there's no rounding error. But if they asked for a decimal, well, let's say we do the nearest tenth here, you can hit your toggle button. So I'd have 169.6 square meters. Right, on this last one, the tricky part here is they give us diameter. Radius is only halfway across, you have to remember. So my radius is 4 inches. Half of 8 is 4. So I have 2 of my circles, so 2 times pi r squared. Then I need my diameter times, or not diameter, circumference times height. So we'd have 2 pi r times height. So 2 pi 4 squared plus 2 pi 4 times 8. So exact form is 96 pi, and you can use this normal equal sign because they're exactly equal. If you're approximating, we switch to this wavy equal sign, which is called approximately. We're approximating. Oh, that's not what I want. So you hit your toggle button, and that'd be 301.6 square inches, and really these should also be labeled. All right, so that's it for our notes for today. Again, you do have a Delta math assignment to work on.